An atom is the smallest unit of ordinary matter that has the properties of a chemical element. They are the building blocks of matter and make up everything around us. But how did we as humans figure this out? With the help of 9 great scientists. The first was Democritus. In 460 BC, the Greek philosopher asked this question: if you break a piece of matter in half and then break it in half again, how many breaks will you have to make before you can break it no further? He thought that it had to end at some point, the smallest possible bit of matter, and this bit was what he called the atom. He figured that the atom was just a little sphere and that in between the atoms there was just empty space. His model looked something like this. The second was Aristotle. He believed that all substances were made of fire, water, earth, and air. He dismissed Democritus' proposition of the atomic idea. He was very influential and many people believed what he said, therefore slowing down the process of finding the correct atomic theory greatly. Aristotle was obviously later proved wrong because atoms make up everything.
2,000 years later.
Thirdly, we have Antoine Lavoisier. Lavoisier was known for his experimentation skills, and he loved to work with mercury. Through this, he proceeded to come up with the law of conservation of mass, which states that during a chemical reaction, matter can neither be created nor destroyed. For example, if you heat 10 grams of calcium carbonate, you'll produce 4.4 grams of carbon dioxide and 5.6 grams of calcium oxide. This equals 10 grams, so you know that no mass has been lost. Lavoisier brought back the conversation of what an atom was after a 2,000-year null. He is known as the father of modern chemistry. John Dalton. He was an English chemist, and in 1808, through his experiments with various chemicals, he showed that matter consisted of lumpy particles of which are atoms. His atomic theory stated that each element is one of a kind because all atoms of an element are identical. All atoms that make up a single element have the same mass. All elements are different from each other because of different masses. A compound is a one-of-a-kind substance of different elements bonded together, and that chemical reactions involve the rearrangement of combinations of atoms. Next is J.J. Thomson. In 1897, the English physicist discovered the electron by studying the nature of electric discharge in a high vacuum cathode ray tube and described electrons as particles much smaller than atoms that had a very large charge to mass ratio. Thomson knew that electrons had a negative charge and felt that matter must have a positive charge. He proposed a model for the structure of the atom that looks like raisins stuck on the surface of a lump of pudding. The raisins being the electrons and the pudding being the cloud of a positive charge. We call this the plum pudding model. Robert Millikan was the scientist, and he performed the famous oil drop experiment in 1909 to figure out the charge and mass of a single electron. What Millikan did was put a charge on a tiny drop of oil and measure how strong an applied electric field had to be in order to stop the oil drop from falling. Since he was able to work out the mass of the oil drop and he could calculate the force of gravity on one drop, he could then determine the electric charge that the drop must have. By varying the charge on different drops, he determined the charge and the mass of an electron. Ernest Rutherford hypothesized that an atom's mass was uniformly spread out in its shape. In the gold foil experiment, he shot alpha particles at a thin sheet of gold. He thought that the particles would travel through the sheet. However, he found that a minute percentage of alpha particles ricocheted backwards. This led him to conclude that most of the mass of an atom was centered in the positive nucleus, while only a small amount of mass surrounded this positive ball. Rutherford's model looks something like this. It contains a nucleus, electron orbits, electrons, protons, and neutrons. In 1924, a French man named Louis de Broglie thought about particles of matter. He thought that if light can exist as both particles and waves, why couldn't atom particles also behave like waves? In a few equations derived from Einstein's famous equation, E equals mc squared, he showed what matter waves would look like if they existed at all. Experiments later proved him correct. It wasn't until 1932 did the English physicist James Chadwick finally discover the neutron. Using alpha particles, He discovered an atomic particle with no charge, also known as a neutral charge. He found it to measure slightly heavier than a proton. The proton-neutron together received the name nucleon. In this project, the Rutherford model is the most current model, and this is what it looks like.